All right, here's an indefinite integral that we need to compute, and it can be done two different ways that I can identify. One, we can use integration by parts to solve this, or two, we could use trig identities to find the antiderivative. I want to show both methods. So for method one, by doing this integral using integration by parts, I'm going to answer this simpler integral, just because I don't feel like writing quite as much. What is the integral of sine squared theta d theta? So I said I was going to use integration by parts. Here's the formula. Integral u dv equals uv minus the integral of v du. I'm going to set u equal to sine theta and dv equal to sine theta d theta. I'm going to split it up that way. And of course that means that du will be cos theta d theta and v will be negative cos theta. And so this integral is equal to negative sine theta cos theta, right? I have u sine theta minus cos theta is v, so I multiplied them, minus the integral of v du. And so what I have here is a negative cos theta and minus the integral of v du. So I have a minus cos theta and a positive cos theta. And that's why I changed the minus sign to a plus, because the two negatives cancel. So I have negative sine theta cos theta plus the integral of cos squared theta d theta. Now, I could do integration by parts again, but that won't really give me what I want. Instead, I'm going to use the trig identity that cos squared theta is equal to 1 minus sine squared theta. And so this is equal to minus sine theta cos theta plus the integral of 1 minus sine squared theta d theta. And when I split that guy up and integrate the 1, I get minus sine theta cos theta plus theta plus c, that's the antiderivative of 1, minus the integral of sine squared theta d theta. Now this is cool. You might think it's not cool, that here's the initial problem here. That's not a good thing. But think about this. We have an equation. What we have is that 2 times the integral of sine squared theta d theta is equal to this expression right here. Can you see why? Here's the original integral, and it is literally equal to all of this. And if these two things are equal, then I can add this to both sides of the equation, and I get what's exactly down here. 2 times the original integral is equal to minus sine theta cos theta plus c. You divide both sides by 2, boom, final answer. So what does this mean for the problem above? So here's what I got on the previous slide. And what this means is that the integral of 1 minus 4 times sine squared theta d theta is equal to the antiderivative of 1 minus 4 times the answer that I got. And by doing some basic algebra and simplifying, the 4 over 2 is 2, and I cancel the negatives and distribute the negative to the theta. What I wind up getting for my very final answer is minus theta plus 2 sine theta cos theta plus c. That is method number 1. So, okay, I promised 2 methods. The second method involves using a trig identity right away. And so I'm going to work with that original problem, that original indefinite integral, and I'm going to replace the sine squared with 1 minus cos 2 theta over 2. And so I don't feel like rewriting it, so let's call the original problem just I. That antiderivative is going to be I. So I is equal to the integral of 1 minus 4 times all of that d theta. Okay? Let's attack that with a little bit of algebra by distributing the minus 4 over those expressions. 4 over 2 is 2, blah, blah, blah. So here's what I have. And I'm going to simplify that just a smidge more. Here I am. This is fantastic. This can be done with a basic substitution where u equals that 2 theta. Total joke. So you get minus theta plus sine of 2 theta. That is the antiderivative of this beast right here. And then plus c. All done. Or are we? I mean, this is the answer from before, right? Minus theta plus 2 sine theta cos theta plus c. Those are not the same expression. But maybe you can see pretty quickly that these two expressions are equivalent because of this other trig identity, that sine 2 theta is equal to 2 sine theta cos theta. And so this piece right here is equivalent to that piece. And so I want to close out by saying that you may be completing a quest exercise in which the answer that you get doesn't look like any of your choices. That doesn't mean that the answer isn't there. You have to have your sheet of trig identities with you, or you have to know them by heart. And you may have to manipulate your response to make sure that it is or is not equivalent to one of the choices given. This can be a pain in the butt sometimes, but it's what we got to do with these trig integrals.